So now that we have imported our data, we can finally work with our data using table functions. But before we get into certain table functions, we must first understand the difference between series and data frames. So series are a one-dimensional labeled array capable of holding any data type, while a data frame is a collection of series that can be used to analyze the data. So a series can be considered the column of a data frame. So all of these values are stored in the food column of the data frame. So in order to create a table, we first have to create series containing the data and make a data frame using those series. So in this example below, our food series contains the different types of food: chocolate, cheese, strawberry, and peanuts, while our cook series contains the different cooks for these foods: Julia, Jerry, Rebecca, and Harry. And finally, we create a data frame that contains the series as columns. So we have our food column and our cook column created from our series, and we also have our index values. So that is the most basic way to create a table. And once we have our table, we can continue to add rows and columns. Columns, we declare new lists as columns, and rows, we use the append keyword. So we start off with our data frame from our last slide with our food and cook columns, and we want to add a new column called restaurant. How are we going to do this? We are going to first declare a new list as a column. So we name our column named restaurant, and we assign it to a list. And our list are the restaurant names. So Denny's, McDonald's, Baskin Robbins, and Texas Roadhouse. So this successfully makes our new restaurant column. Rows are a little bit different to create. Rows, we use the append keyword. So in order to create a new row, we first create a dictionary where we want to add these values. So for the food column, we want to add pizza. For the cook column, we want to add Mario. And for the restaurant column, we want to add Blaze Pizza. So in order to append this row, we do df.append new row, and we set this parameter of ignoring index to be true. So that is how you add a new column or new row to a data frame. We also can rename columns of our data frame. So starting with our first data frame that we created originally with our food and our cook values, we can rename the columns to be edibles and chef. In order to do this, we use our df.rename and set our columns parameter to be the columns that we want it to be. So df equals df.rename columns equals food, we want to rename this to edibles, and cook, and we want to rename this to chef. So that's one way to rename columns. Another way to rename columns is using the index values. So in this case, we're resetting our index itself to be different values. So df equals df.rename index. We want our 0th index to be A, our first index to be B, our second index to be C, and so on. So now we have our index values set to be equal to A, B, C, D instead of 0, 1, 2, 3, 4. So those are two ways to rename parts of our tables in Pandas. Another table function we can discuss are selecting single columns and working with those single columns. Selecting single columns can either result in a series or a data frame. First, we'll discuss a series. So in order to select a single column instead of a series, we use single brackets. So df, the single brackets of our column name, results in our series of food names. Our double brackets, on the other hand, result in a data frame. So df double brackets food results in a data frame of just our single column. We can also select multiple columns. And to do this, we are going to create a new data frame with just those columns. So selecting multiple columns is very similar to selecting a single column using double brackets. So Using double brackets, we select the food and cook columns, which are the columns that we want, and which results in a data frame with only the food and cook columns. We can select rows as well, and not just columns. So we can select a single row or multiple rows using the iloc function. So the iloc function takes in an index number and locates that index and returns the row at that index. So to select a single row, we use df.iloc. In this case, our row number is 0. So df.iloc 0 returns the 0th row, which is chocolate, Julia, and Denny's. And that's what it returns here on the right. To select multiple rows, we again use double brackets with our specified indexes. So df.iloc 0 and 2 selects the 0th row and the 2nd row. In this case, it's chocolate, Julia, Teddy's, and strawberry, Rebecca, Baskin Robbins, and it returns a data frame with these rows. Another table function we are going to learn is filtering. We can filter rows by certain conditions. So we pass in a Boolean argument into our data frame and it returns only rows that fulfill that condition. So in this example, we're going to find only the rows that have a rating greater than 7. So our condition is to keep rows with ratings above 7. We pass this in as an argument to our brackets, and our data frame successfully filters the rows that only fulfill this condition. So in our original data frame, we have rows that are 7, 9, 8, 5, and 10. We only want the ones greater than 7, so that's 9, 8, and 10. Once we pass in this Boolean argument, it returns a data frame with only food, cook, restaurant rating, all the columns, with only the ratings greater than 7. We can also filter rows by multiple conditions using an AND operator as well as an OR operator. So in our previous example, we used the Boolean statement of ratings greater than 7, which keeps rows with ratings above 7, and we're adding a second condition where we're keeping rows whose foods are alphabetically greater than peanut. So we have these two conditions that we're applying to our original data frame, and once we filter all of those rows, we're left with only 2 rows which have 2 foods greater than peanut, strawberry, and pizza, and 2 ratings that are greater than 7, 8 and 10. We can also use the apply function to manipulate our table. So our apply function applies a certain function on certain axes of our table. So in this example, we're applying the sum function across the axis 0. An axis equal to 0 applies to each column, while axis equals 1 applies to each row. So depending on what you would like your function to do, you must properly set which axis you want to apply it to. So data frame df.apply fp.sum axis equal to 0 applies the sum function to each column. So we have our data frame here shown to the left with 2 columns A and B and our index values 0 to 2. Our sum function applies this to each column. So we apply the sum function to the A column first. So we add 6, 4, and 5. Then we apply it to the B function. So we add 6, 4, and 5, and this returns a series with the summations. So both of them sum to 15. So we have A 15 and B 15. Next, we'll talk about grouping.